So number 10 then from the 2022 mechanics paper, a big 10 mark question here, another rotating circle question. A particle of mass 0.1 kilograms is suspended to a fixed point O by a light inextensible rod, so it doesn't change its length and it's got no mass, of length 30 centimetres. The speed of the particle at the top, I'm just assuming it's going this way, the way I marked my angle, is 1.2 metres per second. And part A for 2 marks, using conservation of energy, find the speed of the particle at the bottom. If it's 1.2 at the top, what's it at the bottom? Well, conservation of energy. Now, it depends, notation. What do you put down? Do you put down KE and PE, or do you put E with a small k? It depends on the notation. I think I'll use the notation this time, the sort of engineering one, which is T for the kinetic energy, V for the potential energy. So I'll say this. T, the kinetic energy at B plus the potential energy at B must be the same as it was previously, T at A plus V at A. Now, if I'm measuring the potential energy, I'll need a datum. So here's my datum, B. So my heights are getting measured from B, so B's at height 0. Well, what have we got then? So just filling that in. So that says a half mvb squared plus, now if that's the datum, that'll be 0, will be a half mva squared, that's the kinetic energy at A, plus mg times the height at A, which is 2 lots of the radius. Maybe I'll just call that AB. So that's the energy balance equation then. So that'll be a mark. Now it's just a case of putting the figures. Well, before you put in the figures, there's certain things that can be simplified. The m's will cancel out and you can multiply everything by 2. So that becomes a bit neater. So VB squared would be, those are both gone, will be VA squared plus 2 times this. 2 mgh, which I'm just using the distance AB for. Well, what is that then? 1.2 squared plus, well, that m's gone. That was silly. 2 times 9.8 times, and that's 30 and 30 is 60, so that's 0.6. Now you could either work that out and then take the square root, or just take the square root of it. I'll just work it out. So putting that in gives me 13.2. So VB is going to be the square root of 13.2. So the velocity at B will be, putting that in, 3.6331 and so on. So I'll just say this, the velocity at B is going to be 3.63 meters per second for that mark. Part B, for 3 marks. Find the tension in the rod when the particle's at A and interpret your answer. Now, in the marking scheme, they've started using the angle theta, but you don't need that yet because you're still just in this straight vertical line here. But, again, it's a rotating system. Don't start thinking of centripetal and centrifugal forces and so on. Just think of F equals ma. That's what you're thinking of. F equals ma. To keep that point going round in a circle, it has to experience an acceleration towards the centre. What can provide that acceleration? Well, there's 2 things, especially at the top here. There's the weight and there's the tension in the rod. Those are the 2 parts that could provide this. So that's what I'm going to put down first of all. So we've got this. We've got the tension plus the weight should provide the mass times the acceleration. So there's the tension. Now the weight's actually going to be, it's a plus because it's acting down the way. It's providing it. Don't know why I did that. It's going to be mg just equals m times, now you've got, again, is it v squared upon r or omega squared r? Well, I know the velocity this time, so it's v squared upon r. So that'd be the first mark. Just using F equals ma. What provides this acceleration? What's going to provide the acceleration towards the centre? Well, the only 2 things that are acting on that point there are its own weight, so there's gravity acting on it, and the rod that's holding it there. So these are the 2 parts that provide the force. Well, I don't know what that is. So, and I can't cancel out the m because that's not got an m in it. So now I've got to put it in. So that's 0.1 times 9.8 is equal to, and then on this side I've got, maybe I should have brought them over at the same time, 0.1 times another speed, that's 1.2 squared, over, and the radius is 0.3. So from that I can get t. I'm just going to do the one calculation. I'm going to do that, take away that. So we press the buttons and we get, ooh, negative 0.5, and that'll have to be newtons. Well, that's worth a mark. So what does that it says interpret your answers. What does that negative mean? It means it wasn't looking like this. You didn't need that rod holding this in as it turned. In fact, you needed that rod to push against it. So that rod was effectively getting squashed by the weight. So that means that it was in compression then. It was in compression. It was having to actually push outwards to stop itself getting squashed to get compressed. And that's worth a mark. Maybe I should put the name there, rod. And so part C for 5 marks. Now the angle comes into it. Find the size of the angle when the tension in the rod is 0. Right, well, again, tension. So essentially the whole thing, whenever you've got this, don't think of forces, centrifugal forces and so on. F equals ma. In order for that to stay in a circle, it must be accelerating towards the centre. So in that, what exactly are the forces acting on that point? Well, in order for it to accelerate here, you've got the tension in the rod and you've got the weight which is acting down the way. Those are the only two forces. So those are the ones that must provide this acceleration. So that's the first thing I'll be writing down. T plus W will equal ma. Now what have we got? Now W is actually acting against it here. So what is the component of W in that direction? That triangle's a little bit small. So if that's the weight, and that's the angle, because that angle there must still be a theta, corresponding angles, it's just the angle to the vertical again, that'll be W cos theta, but it's acting against it. So what you've actually got here is T minus W cos theta equals M times, and it'll be V squared upon R you're using for the acceleration. Right, so what have we got? What do we know? We know the tension has to be 0, and you also know that the weight is mg. So what I've got is 0 minus mg cos theta equals mv squared upon r. Now you can knock out the m's, and to avoid that negative, I suppose you could put it all into one side. I could put that over there. So we've got this then. We've got g cos theta, bring it over, plus v squared upon r should equal 0. So that's the first mark. Leave the m in if you like. So that's the equation you're going to work with to find what that theta is, except you don't know what v is. So you're back to part A now, so we're going to have to use that energy equation separately to work out what v is. So we'll just draw this part again slightly bigger. If that's that sector of a circle here, I've got that dotted line there already, because I'm going to need to know the potential energy at P. So I'll need to know this height that's been raised above B. So if that's theta, and that's the radius, and this is a right angle triangle here, that must be next to the angle r cos theta. So that height's going to be the whole line, which is r still, minus r cos theta. So it's r times 1 minus, in brackets, cos theta. Because what I'm going to have to do now is find v. So I'm going to have to use the energy equation. So comparing energies, you can use Ke and Pe, or whatever you like. I'm just going to go for this. The kinetic energy at P plus the potential energy at P will be the kinetic energy at B plus the potential energy at B. I'm using B as the datum. That means B's at height 0. So that says I've got a half m, and I'm just going to call that V for that one, plus mgh, and h is this, mgr times 1 minus cos theta, will equal a half mvb squared, I'll just put it down, vb squared, plus 0. Now, I think there's a couple of marks for doing that, for considering the kinetic energy and considering the potential energy. I've just done them both in one line. But I've got to rearrange that now to get v squared to pop in there in order to solve this. Well, the first thing is all the m's can go. So that's one simplification. You could double everything, so those 2's will go for there and reappear there. I'll do that first of all. So I've got v squared, and that m will go, but there'll be a 2 there instead, plus 2m, oh, I just said that, 2gr 1 minus cos theta will equal, and all of that goes vb squared. So that's going to go across. So now we've got it. So v squared is going to be vb squared minus 2gr times 1 minus cos theta. Right, so that was the energy equation. That was just to get the value of v so I could pop it back in there. Now you've got to pop it back in there. So this line will get a mark when you substitute that. So you've got this, you've got g cos theta plus, I'll just have to put that to the front, 1 over r times vb squared minus 2gr times 1 minus cos theta, just copying it down, 2 brackets, should equal 0. Right, that's worth a mark, and that's what you can solve, because you know everything in there apart from theta, because you know the g, you know the vb, I kept a note of it, there's the vb squared, and you know the radius. Oh, now, well, maybe I'll multiply that bracket out first. 2 cos, so that's going to be, there's a nasty one, vb squared upon r, which you'll recognise. Then this bit, there's 2 parts here now. That r will cancel out, so I've got a minus 2g just, and a minus minus, that'll be a plus, that'll cancel it again, 2g cos theta. Don't look too bad. Now, those can get combined, equals 0. Those 2 can get combined, so combine them, 3g cos theta. And they can go over the other side, 2g minus vb squared upon r. So I'm just obstinately refusing to put in numbers yet until I've got this looking nice. You might think I look better with the numbers in. So finally I've just got to divide that out. That's not looking so nice. So vb squared upon r all over 3g. Run out of space because now I'm going to put my numbers in. 2 times 9.8 minus, and I kept vb squared up here, 13.2 divided by 0.3, which is r, over 3 times 9.8. So I'm going to type that into the calculator, or you could just do in one go. Inverse cos of that whole thing. So typing it all in, you get negative 0.8299 and so on. And then, done that as well, doing the inverse cos of that gives you, I'll put the final answer over here though, so final answer, theta is 146.09 and so on, so I'm going to go for 146 degrees. But that was the worst of it there, I think, and there was only 1 mark.